So we are now on Cessna 206H aircraft. We will be carrying out a daily inspection of this aircraft. Before releasing the aircraft for flight, we carry out a daily inspection. This inspection is in addition to the inspections which we had just discussed. Before releasing this aircraft, before the very first flight of the aircraft, this inspection is required to be carried out. And with me is Mr. Porwal, Mr. Animesh Porwal. He is the chief technician on this aircraft. He will help us out during this inspection. So you can see this aircraft inspections are for fuselage inspections, engine inspections. In the fuselage, it calls for inspecting the skin panels for cleanliness, condition and signs of damage. So we need to see the skin, the aircraft skin all over for the cleanliness, for any damage, for any scratches or something. Rivets, you can see the rivets here. We need to watch the rivets, whether the rivets are there, some rivet has not sheared off. So all over the fuselage, we need to inspect this thing. Check for security and operation of door and their latches, check condition and the hinges. So you can see this door, this is the main door of the aircraft. We need to look at the hinges. These are the hinges of the aircraft. We need to watch the hinges. We need to look at the latches and the security of this lock. Like, we need to see that the aircraft is locking properly. The doors are locking properly. Check all transparent panels and windshields for cleanliness and condition. You can see the transparent panels here, all over there are transparent panels. We need to watch the transparent panels for cleanliness, for the security and condition. Now, check cockpit floor assembly and cockpit for cleanliness, condition and security. Again, going into the cockpit, we check for the general cleanliness and the general condition. Check seats and cushions for condition and security. So you can see the cockpit here. It calls for checking the cockpit floor assembly and cockpit for cleanliness, condition and security. The complete floor has to be checked for neatness, for cleanliness, for condition. Check seats and cushions for condition and security. We need to check the seats, the cushions, whether they are in order. Seat belts, shoulder harness for condition and security. You can see the seat belts here. These are the seat belts. The shoulder harness, we need to check that the seat belts are in proper order. They are not damaged. Check fire extinguisher for leaks and security. You can see here there is a fire extinguisher. This fire extinguisher, we need to check for the leaks and whether the fire extinguisher is properly secured. Check first aid kit for proper anchorage and ensure that the seal is intact. There is a first aid kit in the aircraft. It is just behind. So we need to check whether the first aid kit is properly anchored and that the seal is not damaged. Ensure that the upholstery is securely anchored. Here the upholstery and everything, you need to see that the upholstery is securely anchored. All placards and correction cards are in position. So there are various placards in the aircraft. You need to watch all placards, whether the placards are in proper order, they are properly fixed, and all the required placards are in place. Now coming to undercarriage, you can see the undercarriage here. This is the main undercarriage, the main landing gear. We need to inspect the main landing gear for its cleanliness and condition. We need to do a visual inspection, whether all the things are in place, whether there is no crack. The main and nose wheel tires for creep marks, general condition and correct inflation. You can see this is the main wheel. We need to see that there are no cuts, no damage in the tire. The required creep marks are in place. The required locking, this split pin, this is properly there. We need to inspect the main wheel. Similarly, this is the left wheel. Similarly, you need to inspect for the right wheel and the nose wheel. The brake system for leakage of fluid at joints and for satisfactory operation. You can see the brake system here, the brake unit. We need to watch, we need to see that there are no leaks in the brake unit. The brake liner is there. The brake liner has not worn off and there are no leaks and no damage in the brake unit. This is the nose landing gear. we need to watch for the cleanliness, proper strut extension, the attachment of the torque links, all the bolts are in place, all the locking mechanisms are in place, and there are no leaks in the shock strut. The nose wheel, we need to watch the nose wheel, the proper locking is there, proper anchoring is there, there are no cuts on the tires, and proper inflation is there. So this is a tire pressure gauge, we call it a TPG. It is properly calibrated. We need to have a calibration tag. This calibration also has got a validity. Before using this instrument, we need to ensure that your instrument is properly calibrated, it is within the specified date limit, and then we need to measure the tire pressure. Please see the tire pressure, and we will just show you how we measure the tire pressure. So before every flight, we need to measure the tire pressure, whatever is mentioned by the manufacturer. The tire pressure has to be checked. The tire pressure has to be checked. It is 49 plus minus 3 psi. So you can see it has come to 48 psi, and the requirement is 49 plus minus 3 psi, that is 46 to 52 psi. So it is well within the range. Similarly, we check it for all the tires. So now we come to flaps, the inspection on flaps and the main plane. We have to inspect the skin panels of the main plane and flaps for any signs of damage. We need to check the flap rollers. You can see the flap track here. The flap track, we need to see whether the track has not worn off. The rollers are in place. So all the tracks and the rollers have to be inspected on both sides, on the left side and as well as the right side. The lift struts for damage, straightness and security of attachment. These are the lift struts. We need to check whether there is no damage here. They are securely attached. Both sides, you can see one side, bottom and at the top. Similarly on the right side also. We need to check the aileron hinges and excessive play for corrosion and security. So these are the ailerons. You can see we need to check these ailerons, their movement, so that there is no binding in the movement. You need to feel that movement. You need to feel that there is no binding. You need to see whether the trailing edge is proper, there is no distortion in the trailing edge. The skin panels, the rivets, everything is in place, there is no damage. So similarly, this is the left side, you need to watch on the right side also, the ailerons. Now going to the tail plane. So this tail plane, you need to inspect the tail plane, the fin, the rudder, the horizontal stabilizer, the elevator, the trim tab, all over the area. You need to see whether this tail plane is clean, there is no damage, there is no distortion, all the rivets are in place, there is no shearing of the rivet, plus the elevator hinges, the bolts are in place, the movement, you need to check the movement of the elevator, that there is no movement, there is no binding in the movement, your cables are in place. Similarly in the rudder, watch the hinges, the bolts are in place and the movement is proper. So this is your inspection about your tail plane. Coming to the trim tab, check the hinge, whether the hinges are in place, the skin panel is okay, there is no shearing of the rivets and your surfaces are neat and clean. These are the static discharge wicks. You need to see these static discharge wicks, they have not worn out, they are in place. The static discharge, you can see they are all over the tail plane. So you need to watch these static discharge wicks too. So now coming to fuel system, we need to take a sample of the fuel. Ensure that the fuel, there are no sediments in the fuel, there is no dirt in the fuel sample. The fuel sample is free of water, moisture. So you can see this is a paste, water finding paste, which we use to ensure that our sample, our fuel in the aircraft tank is free of moisture. This is your fuel sampling bottle through which we will take the sample. So you can see there are various drainage points, drain points for the fuel tank. We take the sample from the different points. This is one point from where the fuel sample is being taken. From the first point we want to ensure that the fuel is free of dirt, there are no sediments. This is another point. This was the rear point, this is the forward point of the fuel tank. So we want to ensure by taking the sample from different points that the fuel is almost free of dirt, there are no sediments, and the fuel is safe for use. This is a forward fuel drainage point. This is the gasculator point. This is the lowest point in the fuel system. So we want to take the fuel sample from the lowest point also to ensure that the fuel is safe and our fuel system is free of any sediments. So you can see the fuel sample is free of all the sediments, there is nothing there, it is absolutely clear. So now I am pretty sure that my fuel system, my fuel tanks and my fuel is safe for use. After taking the samples, we will also ensure that the fuel tank caps which are there on the top of the wing, they are secured. You can see he is ensuring that the fuel tank caps are secured, properly secured. The fuel tank cap you can see there. There are vents also in the fuel tank cap. We will ensure that the fuel tank vents are also clear, and similarly on the right side also the fuel tank caps are to be ensured that they are safe. Then these are the vents, this is the vent line. We ensure that the vent line, this thing is not bent, this is clear, there are no obstructions in this. This is about the fuel system of the aircraft. Now, so this is the propeller, you can see we need to ensure that the blades, leading edges have no damage, the blades are okay, the spinner is properly secured, there are no leaks in the propeller. This is the oil panel. We will open this panel, we need to see, you can see the oil dipstick here, the oil tank cap. We will open this oil tank cap and ensure that the oil quantity is sufficient. You can see this is the oil dipstick. You can see the oil. We will clean this dipstick with a clean cloth and we will dip it again and find out the quantity of oil in the oil tank. So you can see here, this is the maximum mark and it is slightly less than the maximum mark, which is 11 quarts. The oil in the tank at present is sufficient for a safe flight. So now this was about the aircraft airframe part. Coming to the engine, we will open the engine cowlings. Before the flight, we will open the engine cowlings and check the engine. We will do a visual inspection of the engine and check whether engine parts, engine components, they are all in place and there is no damage. And after the engine inspection is done, the cowlings will be put in place. We will check for the security of these fasteners. These are the fasteners, whether the fasteners are properly secured, and it will be followed by a proper engine ground run up to see whether all the parameters are within the range and the aircraft is safe for flight. So please remove the cowling, and now we are going to see how the cowling is removed and how we carry out an engine inspection. So you can see the various fasteners here, the various fasteners being opened. These are the fasteners. There are fasteners at the top also. So while putting the cowling in place, back in place, we need to be very sure that all the fasteners are properly secured, because in case if some fastener opens during flight, then it may be dangerous. So it's very important to see that the fasteners are secured. So see, the cowlings have been removed. You can see the engine now. This aircraft, Cessna 206, has got a 6-cylinder Lycoming engine, Lycoming IO 540 engine. Now coming to the engine, this is the right side of the engine. 3 cylinders. We see whether all the screws, they are in place. There are no leaks. There are no leaks. All the fuel lines, they are in place. The spark plugs are properly anchored. So now the cowlings have been opened. This is Lycoming IO 540 engine on the Cessna 206 aircraft. It's a 6-cylinder engine. We are on the right side. These are 3 cylinders, first, second and third cylinder. Then we need to ensure that these screws are in place. There are no leaks. General inspection, the visual inspection, all the things are in place. There is no damage. These are the spark plugs. You can see the 3 spark plugs. The spark plugs are in place. The fuel lines, they are not broken. You need to watch the fuel lines all over. The fuel lines are not broken. There are no leaks in the fuel lines. This is the crankcase. You need to look at the crankcase, that all the anchoring bolts, they are in place. There are no leaks in the crankcase. These are the engine mounts. The engine mounts, the mounting is proper. The creep mark on the engine mounting bolts, they are in place. These are the shock mounts. You need to see that your shock mounts are not damaged. Your exhaust muffler, you can see this is the exhaust muffler. You need to watch your exhaust muffler. You need to look at the weld seams. Very important that your weld seams are intact, they are not open. You need to see the anchoring. The anchoring is in place. Your ducts, they are not damaged, they are in place. These are the baffle fins. You need to watch for the baffle fins. The baffle fins are okay. The cylinder fins. So now you can see the engine from the top. You need to ensure that your cylinder fins, these are the cylinder fins. You can see these are the cylinder fins. You need to see that there is no breakage, there is no damage in the cylinder fins. The fuel lines, these are the stainless steel fuel lines. Thin lines, there is no damage, they are secured properly. There are no leaks. The spark plugs are in place. All the attachments, they are in place. This is your injector. You need to ensure that your mixture, your throttle and your governor, everything is in place. There is no damage. All the split pins are in place. So all the components, whether it is the fuel manifold, the fuel injector, the compressor, the fuel lines, the various tubings, you need to ensure, need to do a visual inspection and ensure that everything is in place. Here you can see the oil cooler. The oil cooler, you need to ensure that your oil cooler locking is in place. There are no leaks in the oil filter. This is the oil cooler. Then you have the magnetos here. You need to ensure that all the electrical connections in the magnetos, they are in place, they are properly secured. So after doing a complete visual inspection of the entire engine, we will put back the cowlings and we will do a engine ground run. So now we are inside the Cessna 206H aircraft. This is the cockpit. This is the pilot seat where I am sitting. This is the instrument panel. We will start the aircraft. We'll show you the procedure how we start an aircraft. These are the keys for this aircraft. This is the ignition switch. You can see the ignition switch here. We have put the keys here. At present it is in the off condition. This is the parking brake. I'll put the parking brake. Before starting, we need to put the parking brakes, press the rudder pedals and pull the parking brake. The parking brake is on now. These are the cowl flaps. This is the cowl flap control. I need to open the cowl flaps. I have opened the cowl flaps. This is my fuel tank selection. This aircraft has got two fuel tanks, one in the left tank and one in the right tank. So I have put the fuel tank selection in the both position so that the fuel can simultaneously be supplied from both the tanks. This is your throttle control. This is your mixture control, propeller control, and this is your mixture control. So before starting, I need to adjust my throttle to the quarter condition. Throttle is in the quarter condition, slightly in. This is my standby battery switch. I need to check my standby battery for 10 seconds. When I select this standby battery switch on the test mode, this lamp should glow and I'll hold it for 10 seconds and then put it in the arm condition. So now my standby battery is armed. You will see this is the PFD and the MFD. This screen has started glowing. This is the Garmin 1000 avionics system. This is my digital instrument. You can see a lot of parameters here on the screen. Manifold pressure. This is the RPM. This is the fuel flow. This is the oil pressure, oil temperature, cylinder head temperature, exhaust gas temperature, fuel quantity, left tank, right tank. This is for the electrical, bus voltage, battery voltage. And these are the various instruments. You can see the outside air temperature. Now with this screen on, I'll put the master switch on. My master switch is now on. Throttle is already quarter inch in. Now I am supposed to prime the engine. This is my mixture control. I'll put the mixture control in the full rich condition. This is now full rich condition. And I will put the fuel pump switch on. With the fuel pump switch on, I need to see this fuel flow gauge here. This should register. The fuel flow gauge should register so that is an indication that your engine is getting primed. With the mixture full rich, throttle quarter inch, and now I'm putting this, you can see this fuel pump switch. This is the fuel booster pump. I'm putting the booster pump on. Listen the sound, and it has registered, already registered now. Now the mixture is out and I am going to start the engine now. See the ignition switch off position, brakes on, and I'm taking the clearance from outside and engaging the ignition switch to start the engine. See, with the engine on, now the engine is on. The engine is on. The very first thing you have to watch for when you switch on the engine is the oil pressure. The oil pressure is supposed to register within 30 seconds to ensure that your oil has started flowing within the engine and proper lubrication has started taking place. This is my RPM. You can watch here, this is the RPM. I need to put the engine on 1200 RPM so that the oil temperature comes to the limit. See the oil temperature here, it is just starting in the green range. I have put it in a different mode here. You can see the actual value of the oil temperature here. It is 100 degrees Fahrenheit at the moment. So I'll wait for the oil temperature to slightly increase so that it is comfortably in the green range, and then we will move ahead. So I have put the engine on 1200 RPM. You can see the RPM here, 1200. All the parameters are in the green range. See the fuel flow, the oil pressure, oil temperature is also now in the green range. The cylinder head temperature is yet to touch the green, and other parameters are also within the range. Now I am waiting for my cylinder head temperature to come in the green range. It is, you can see it is 175 degrees Fahrenheit, 180 degrees Fahrenheit for cylinder 1 here. So CHT is also now in the green range. This ensures that your engine has achieved the oil temperatures required for doing the engine ground run. Since the oil temperature is already in the green range, I am moving ahead. I'll take the RPM to 1800. So with this, I'll push the throttle gradually inside and take the RPM to 1800. Watch it. So now I've started increasing, pushing, and the RPM is increasing, you can see. Watch the RPM increasing here. It is 1500. While doing the run, we need to be very careful about the brakes. The brakes should be in place. RPM is 1800. RPM is 1800. At 1800 RPM, I need to check my pitch, propeller pitch. This is my propeller pitch. At the moment, it is in the fine position. I'll put it in the coarse mode and watch the RPM drop. So I'm pulling this propeller pitch, and you watch the RPM here. You watch the RPM here. See this pitch control. I am pulling it in the coarse condition, and watch. This is the drop from 1800. It dropped to 1580. So you can see it was almost a 220 RPMs drop, which is well within the limits. At 1800 RPM, I am also supposed to check my magneto drop. Magneto drop means I'll put the ignition switch from both condition. You can see the ignition switch here in the both condition. At the moment, it is in the both condition. I'll put it in right mode and in the left position, and in doing so, I'll check the RPM drop. The RPM drop should be within the limits. So you can see my throttle RPM in 1800. I'm putting it from both to the right position. See, it was 1720. From 1800 it dropped to 1720. That means a drop of 80 RPM. Now it is back to 1790. I'll make it slightly more, 1800, bring it to 1800. You see it is 1800 again, and I am putting it to left mode. Now the ignition switch to left mode, and you see the drop. I'll do it again. See, from 1800 it dropped to 1740, that means a drop of 60 rpm. So there was a drop, on one side it was a drop of 80 rpm, and on another side it was a drop of 60 rpm. So this is well within the range. So now from 1800, I'll go for full throttle. You need to watch the RPM here, and the manifold pressure. So I'm going to give it full throttle. Full throttle means maximum power. So here we go now. Throttle pull in, max RPM 2650, manifold 28.5. You can see the RPM, maximum RPM and the maximum manifold. It is well within the range. So I'm putting the RPM, I'm putting the throttle back, gradually putting it back, gradually reducing power. You can watch the RPM gradually decreasing. You can see the RPM gradually decreasing, the manifold pressure gradually decreasing. And all along you can see the ranges, all the parameters are within the green range. You can see all parameters are within the green range. The fuel flow, the oil pressure, the oil temperature, the cylinder head temperature, fuel quantity, everything, the manifold pressure, everything is within the green range. That means your aircraft is perfectly okay to fly. So I'm gradually decreasing the RPM. Now we will come to 1000 RPM. See, gradually it is decreasing. It is decreasing. You can see the RPM gradually decreasing here. Now it is 1000, 1020. From here, 1000, I'll go to the idle RPM, which is the minimum RPM. That means throttle full out. I'm going to check the idle RPM, that is the minimum RPM. See the minimum RPM, it is 600 at the moment. I will check my mixture control also here. I'll gradually pull this control out and see the drop in RPM. It should increase a bit and then drop. It is 610, 620, you can see. Yeah. See, your RPM has increased and decreased. So this is the check for the mixture. With the mixture check, after this, I'll again increase the throttle. I'll again increase the RPM. I'll take it to 2000, clear my spark plugs, clear my engine. See the RPM increasing now. And now I'll bring it back to idle. My engine is clear now. I'll bring it back to idle and then I will switch off. So you've seen all along your parameters are in green range. To cut off the engine, to switch off the engine, I will pull this lever, the mixture control out, which will stop the supply of fuel to the engine, and the engine will eventually shut down. You can see I am pulling this lever out, the fuel supply is shut and the engine has cut. The engine is out now. I put the ignition switch back to off. I am switched off this screen, switch off the master and switch off the arm condition. After the ground run, I also need to ensure that my controls are proper. There is no binding in the controls. I'll ensure that my controls are okay. There is no binding in the controls. The ailerons are operating properly. The elevator is operating properly. At the same time, my instruments, my standby instruments, my other instruments and switches, circuit breakers, everything is in place. There is no damage. So with all these inspections, you have seen the inspection outside, the fuselage, the engine inspection, the landing gear inspection, the cockpit inspection, the instrument inspection, the instrument panel inspection and the ground run. After satisfying ourselves that the aircraft is completely safe for flying, we will release the aircraft for further flights. Thank you.